Go back to the first episode of this channel, and you'll find us making a promise we didn't fully understand yet. We said the Drake equation was a rough sketch, a whiteboard scribble for 1961 that gave a room full of scientists something to argue about at the first ever SETI meeting, not an actual answer to why the universe looks so quiet. Footnote 1. We said the silence itself might just be what the math predicts. And then we said something we didn't examine closely enough at the time. We keep looking for life that looks like us. That sentence has been doing more work than we let on. Every episode since has, in its own way, circled back to it, testing a different reason the sky might be silent, without ever standing back to say, these reasons add up to something. For some things, actually, for separate, independent, non-mutually exclusive answers to the single loudest question this channel keeps returning to. Where is everybody? This is the episode where we stop pretending those four answers were unrelated. Detection, timing, population, geometry. Say them out loud together, and they sound like four different shows. They aren't. They're four load-bearing walls of the same building, and we built the building one episode at a time without showing you the blueprint. Here's the blueprint. The thing about detection. Answer 1. Maybe they're out there, transmitting, and we're just not listening the right way. 65 years of radio SETI have found nothing. Footnote 2. Not a hint, not a maybe, not an interesting anomaly that later resolved into noise. 0. And for a long time, this show treated that silence as suspicious, evidence against the idea that intelligent life is common. But go back and look at what the search actually was, and the silence starts to look less like evidence and more like a methodology problem wearing evidence's clothes. The search was designed in 1959 by people for whom narrowband radio was the most sophisticated communication technology anyone had ever built. Footnote 2. The entire framework, the hydrogen line, the water hole between hydrogen and hydroxyl, the assumption that any civilization worth finding would be broadcasting on a frequency convenient for 1,959 human receivers, is a projection of what we had, not a law about what's out there. Footnote 2. Even the underlying growth model has the same problem. The Kardashev scale assumes civilizations expand by consuming more and more energy in stages forever, which is not a law of physics. It's a straight-line extrapolation from about 200 years of human industrial history, applied to timescales of millions of years, to species we've never met, based on one data point. Us. Footnote 2. It's worth noting the field didn't just complain about its own limitations and stop there. The G-infrared survey searched for waste heat signatures of hypothetical Dyson spheres across hundreds of galaxies, on the theory that even a civilization uninterested in radio would still have to obey thermodynamics. Footnote 2. Nothing came back conclusively there either, but the fact that the search now includes look for the heat exhaust of a Kardashev Type 2 civilization alongside listen for a deliberate radio greeting is itself evidence the field is trying to widen the aperture, not just rerunning the same 1959 assumptions with better antennas. Breakthrough Listen surveyed 2,623 stars and came back with 0 candidates. That's a real, meaningful null result. And it's exactly consistent with two completely different explanations that this show has spent an entire episode refusing to conflate. Either nobody's out there transmitting, or everybody's out there doing something we didn't think to listen for. The field itself has started taking the second option seriously. The shift from narrowband signal hunting toward broader anomaly detection is a tacit admission that the 1959 framework was too narrow to trust as exhaustive. And underneath all of that sits the deepest assumption of all, the one that doesn't get interrogated nearly enough, that an advanced civilization would want to talk to us in the first place. Footnote 2. We spent this entire subseries establishing how alien life might actually be. It would be strange if the one thing we never questioned was whether it shares our impulse to shout into the dark and hope something shouts back. It is fascinating. A 65-year search returning a null result is not, on its own, informative. It is only informative relative to what the search was capable of finding. It would be illogical to conclude the sky is empty from an instrument that was only ever listening for an echo of ourselves. Detection, then, isn't really an answer about the universe. It's an answer about the instrument. And an instrument that only knows how to recognize its own reflection will report an empty room every single time, right up until it doesn't. And it's all about timing. Answer 2. Maybe everybody who could be signaling hasn't gotten there yet, or didn't survive long enough to. This is the great filter argument, and it reframes the entire question around a single, unsettling matter of direction. Footnote 3. If the improbable step that filters out nearly every civilization sits behind us, somewhere in the deep evolutionary past, before intelligence, before multicellularity, before the eukaryotic cell, then the silence is just what a young universe sounds like, and the future is statistically wide open. Footnote 3. If it sits ahead of us, in the technological adolescence, every sufficiently advanced species has to survive, then the silence isn't an absence. It's a track record, and it's not a comforting one. The behind us case has real candidates, and the argument only works if both directions have genuine evidence behind them, not just the frightening one. The origin of the eukaryotic cell, the single evolutionary event that made complex life possible at all, took roughly 2 billion years to happen exactly once on a planet that had already had simple life for 1 billion years before that. Multicellularity, by contrast, appears to have evolved independently dozens of separate times once the eukaryotic cell existed. Footnote 3. That's a real asymmetry. One hard step that might be a genuine cosmic bottleneck, sitting right next to an easy step that clearly isn't one. If the eukaryotic cell really is the filter, it's already behind us, and the future is more open than the existential risk numbers alone would suggest. Those numbers, though, are worth sitting with. Toby Ord's existential risk estimate puts the odds at roughly 1 in 6 this century, and the dominant threats aren't asteroids or supervolcanoes. They're the ones we built ourselves. Engineered pandemics, unaligned artificial intelligence. Footnote 3. The doomsday clock sat at its closest ever setting in January 2026. Footnote. In 2 Cold War near misses, Arkhipov in 1962, refusing to authorize a nuclear torpedo launch during the Cuban Missile Crisis. Petrov in 1983, sitting on a false satellite alarm rather than reporting it up the chain, are both in this framing single individuals standing between ahead of us and behind us for an entire species on a random Tuesday, for reasons that had nothing to do with policy and everything to do with a personal hunch. Here's the complication this show refuses to sand down. Sandberg, Drexler, and Ord's dissolving the Fermi Paradox shows that the silence itself is statistically compatible with almost any answer to the behind us or ahead of us question. The math doesn't resolve the argument. It just tells you the argument is still live. So, if life can find a way to build a civilization capable of asking whether it's going to survive itself, whether it actually survives itself is, historically speaking, still very much a live question. Ask Stanislav Petrov. Ask Vasily Arkhipov. Actually, you can't ask them anymore. But you can ask what would have happened if either of them had made a slightly different call on a slightly worse day. Timing doesn't tell you whether the universe is quiet because intelligence is rare or because intelligence doesn't last. It tells you those two explanations are, mathematically, wearing the same disguise, and that whichever one is true, we are, right now, inside the part of the story where it would still matter. So, then there's this thing about population. Answer 3. Maybe simple life is everywhere, and complex, technological life is the rare part. This is the reconciliation this show had to make explicitly because 2 of our own episodes seemed to disagree with each other until we drew the distinction properly. Life at the edge of physics, argued that the checklist for life in general, carbon, water, moderate temperatures, is too narrow because extremophiles alternative biochemistries and even exotic proposals like Jovian atmospheric life or neutron star nuclear chemistry suggest life's actual requirements are far looser than the one example we've ever directly observed. Footnote 4. The rare Earth hypothesis argued the opposite direction, for a narrower target. Complex, differentiated, technological life may require an entire non-repeatable stack of improbable conditions stacked on top of each other. Both are true for different definitions of life. The galactic habitable zone alone rules out roughly 90% of the Milky Way stars before a single planet is even in the conversation. Footnote 5. A large, stabilizing moon, the specific low-probability product of one giant impact at one particular angle at one particular moment, keeps a planet's axial tilt from swinging chaotically instead of gently. A working carbon silicate cycle needs active plate tectonics just to function as a thermostat at all, and Venus and Mars each show a different way that thermostat can fail permanently. Even Jupiter's role, long treated as a settled cosmic bodyguard story, turns out to be a genuinely disputed question in the current research, not the tidy protective narrative popular science usually tells. And that's all before you reach the biological ladder. The eukaryotic cell, multicellularity, tool use, metallurgy, each one another improbable rung stacked on everything the planetary conditions already had to get right. Footnote 5. None of this required either episode to be wrong. It required this show to admit it had, without meaning to use the word life to mean two different things in two different scripts, and that the universe was never obligated to pick one definition for our convenience. So population, as an answer to the silence, comes with an asterisk this show insists on keeping visible. It is very likely not lonely out there, if you're asking about life in the broadest sense. It may be very lonely indeed if you're asking about anyone capable of building a radio telescope or caring whether we found them, which leaves one possibility this show hadn't fully priced in until 2 episodes ago, that even if detection, timing, and population all break in our favor somewhere out there, the universe itself might still refuse to let two civilizations meet. And then the math about geometry. Answer 4. And it's the strangest one, because it doesn't require anyone to be wrong, unlucky, or missing at all. It just requires the universe to be the size it actually is. Part 1 of this argument was the physical limit half. The rocket equation's exponential mass energy cost isn't a problem better engineering solves. It's baked into the mathematics of carrying your own fuel. Laser sail concepts like Breakthrough, Starshot solve the fuel problem and immediately hand you 3 new ones. Sail survivability, interstellar dust erosion, and the detail most coverage skips entirely. The current concept is a flyby, with no deceleration mechanism at all. Generation ships run into a genuine, unresolved disagreement in the population genetics literature over how many people you'd actually need to keep a crew genetically viable across centuries. Many thousands by one estimate, as few as roughly 100 by a contested alternative. In relativistic time dilation, the one loophole popular science loves to reach for, turns out to be a trade, not a solution. You can arrive within your own lifetime at the cost of a one-way severance from everyone you left, and even that trade requires exactly the sustained energy expenditure the rocket equation already ruled out. Footnote 6. Part 2 took the harder half. Not whether we can go fast enough, but whether causal contact between two civilizations is even a thing the universe permits. The correction worth repeating clearly, because it's the one popular explainers get backwards. Relativity doesn't forbid speed. It forbids causal contact faster than light, a much stricter, much stranger rule. The Alcubierre-Warp metric is a real solution to Einstein's equations that would get around it, and it has one well-known, decades-old catch. It requires exotic matter with negative energy density, which may not exist in usable quantities, if it exists at all. The genuinely interesting update, and the reason this episode isn't just repeating a decades-old objection, is that research between 2021 and 2024 produced positive energy warp solutions that narrow the required exotic matter budget dramatically, without closing the gap entirely. And the M-Drive saga sits right next to that hope as a cautionary tale. A propulsion concept that appeared for a few genuinely exciting years to produce thrust without propellant, seemingly violating momentum conservation as we understand it, until more careful, better isolated measurements found the anomalous thrust wasn't real. Footnote 7. The field wanted the wall not to exist. The wall did not care. So, if I am able to calculate with precision how much the required exotic matter density has decreased since 2021, I am considerably less able to calculate why a species would spend a century searching for a loophole in a law that has, so far, held every single time it has been tested. I suspect the search itself is the more interesting data point. Geometry, unlike the other three answers, doesn't ask whether anyone is out there, or whether they're broadcasting, or whether they survived long enough to matter. It asks whether out there and here we're ever going to be able to have a conversation in the first place. And so far, the honest answer is probably not, on any timescale either civilization would recognize as relevant. So, let's take a moment to synthesize our thoughts. So here's the shape of the argument, laid out all at once instead of scattered across 4 episodes over several months. Detection says, they might be signaling and we might not know how to listen. Timing says, they might not have survived long enough, or we might not have either yet. Population says, they might not exist, not in the complex technological sense, no matter how common simple life turns out to be. Geometry says, even if all 3 of those break in the universe's favor somewhere out there, reaching us, or us reaching them, might not be a thing that happens on any timescale that matters to either side. Here's the part that took 4 episodes to earn the right to say plainly. These 4 answers are not competing with each other. They're not 4 rival theories where finding evidence for one weakens the others. They're independent, non-mutually exclusive, and this is the uncomfortable part, they compound. If even one of them is fully true on its own, the sky could be silent for that reason alone. If 2 or 3 of them are simultaneously partially true, which the honest current state of the evidence suggests is more likely than any one of them being the whole story, the silence stops being surprising at all. It becomes close to the only possible outcome. If you're new here, if this is the first episode of this channel you've ever watched, here's what several months of standalone episodes were quietly building toward without ever telling you. You don't need to go back and watch 6+ episodes to understand the through line anymore. You just watched it. Detection, timing, population, geometry. That's the whole argument, in the order this show discovered it, compressed into 20 minutes instead of 4. That's not a nihilistic conclusion. It's the opposite of one, if you sit with it for a second. Because it means the universe was never withholding an answer from us out of cruelty or indifference dressed up as mystery. It was just doing arithmetic, detection bias, existential risk, evolutionary contingency, and the geometry of space-time itself, all stacking quietly on top of each other the entire time, whether or not anyone was around to add them up. We were around to add them up. That's the part worth sitting with. There's still a lot of universe left to look at. We just spent 4 separate investigations finding 4 separate reasons it might be looking back at an empty room instead of a crowded one. And somehow, that didn't make the room feel any less worth standing in. If detection, timing, population, and geometry all have to break in exactly the right way for 2 civilizations to ever say hello, then every single time it happens, if it's ever happened anywhere in 13 billion years, it is not a small thing. It is not a footnote. It's the rarest kind of event the universe is capable of producing, and we are, provably, standing inside one instance of the conditions required to produce it. Next time, what happens when you stop asking whether we can reach another civilization and start asking whether we could ever reach another galaxy permanently, as the universe itself expands faster than light can cross the gap. It's a Tuesday. There's still a lot of universe left to look at.